u2. Two adjacent sides of the regular hexagon are given in vectors u and v. Label the remaining sides. Okay, so let's do the ones that are pretty easy. What's the top one going to be? What's the top one? Negative what? U. And I'm sorry, my u's and v's look similar, so I'll do my best here. What about the one opposite of v? Yeah, negative v, right? Nice. So you just have two more to do here. So how would you go about figuring out what this, you have two vectors left here. How do you figure it out? It's going to be some scalar combination of u and v. So how about this one right here, top right one, Tanmay? What's that one going to be?
You can split up any hexagon into equilateral triangles by drawing
Yeah,
diagonals.
correct. You can. Yes, that's correct.
So you can draw a diagonal if you want.
Got it. So if we wanted to move u and v around, how would we construct this one? How would we construct this one right here?
Top right ends up being v minus u.
What does it end up being?
V minus u.
Oh, it ends up being v minus what?
U.
U. Ends up being v minus u. How do you end up getting that? Well, one way to visualize it would be, let's use the snipping tool here. I like this. Let's see if it actually, come on. Is it actually going to give it to me here? Let's see, here's u, right? So what can I do with this? Let's see, it's probably going to blow it up again. It did that before. Let's see. Yeah, it did. Okay, ready? So if I cut this here, if I did negative u, what does that look like? It looks like, roughly looks like this, right? That's negative u. Where could I place that? At the end of, I could put it right here, correct? So where would v minus u be if I did it this way? Where would v minus u be? This diagonal right there. And is that this one right here? It is. So what's the other one going to be? If that's v minus u, what's the other one going to be? It's the opposite of that one, right? So what's it going to be?
Negative v plus u.
Or just you could write it as u minus v. Flip it around. Unit vector, what do you divide it by? It's magnitude, right? So you're going to want to have this vector, here's the original vector, 0.06 comma negative 0.08. I'm just writing it in that form instead. And what do you end up dividing it by? The square root of 0.06 squared plus 0.08 what? Squared. What is that? What's that magnitude come out to be? What does it come out to be? Is it 0.1?
Yes.
It is 0.1? Okay. So this is 0.1. So you have that same vector right there. So what's the vector turn out to be? 0.6 comma negative 0.8. So that's in the same direction. That's in the same direction, but what's the magnitude of this one right here? What's the magnitude of this one? 1. Correct. Nice. So 5i minus 7j, like this. 5i minus 7j is 5 times what? 1 comma 0 minus 7 times 0 comma 1, right? So what's that? 5, 0 minus what? 0, 7. And if you did the vector addition there, what do you end up with? 5 comma negative 7. So this right here is just a different way of writing this right here.
So how would you graph that though? That's
How would you graph it?
Yeah, that's what
How would you graph it? You would go over 5 to the right. So 1, 2, 3, 4, 5. So that's, what does that represent? 5i. And what do you add to it? Negative 7 what? J. So that goes 1, 2, 3, 4, 5, 6, 7.
Oh, and the vector
7j.
is from the origin to there.
No, from here to
Yeah.
there. Yep. So this vector right there, that is 5i minus 7j.
Okay, cool.
Yay!